questions this morning from your review?
I have a question. I watched the video. Did you already do it?
I'll go through it again. Mostly because it's one of those questions that you're going to see multiple times. So page 81, question 19. Car accelerates uniformly from rest at the rate of 2 meters per second squared for 6 seconds, then goes at a constant velocity for 0.5 minutes. Finding the brakes are applied, the vehicle slows down at a uniform rate and comes to rest in 5 seconds. Find maximum velocity of the car and the total displacement. So, again, 3 stages to this question. In stage 1, what's happening? No, I just want words. What's happening in stage 1?
Accelerating.
Okay, so he's starting basically from rest and accelerates. In stage 2, what's happening? Constant speed. So he's set at cruise control and he's going at constant speed. Stage 3, what is happening? He's what? Decelerating until stops. Okay? So those are the 3 things that happen. In stage 1, he starts with the initial velocity of 0 meters per second. It gives us his acceleration. What is his acceleration? 2 meters per second squared. And how long does he accelerate for? 6 seconds. Alright, so how fast is he going at the end of 6 seconds? 12 meters per second. He's accelerating every 1 second he goes 2 meters per second faster. So if for 6 seconds he's accelerating at that rate, he's now going 12 meters per second at the end of it. Okay, let's also calculate what the distance is in that sense. Okay, so the distance in this case, what is my given information? What was the information given to me in that first stage?
V1.
V1.
Acceleration.
A
Time.
and time. And I want to find what?
Distance.
My distance, my displacement, right? So which one of your 5 deals with V1, A, and T to get D? Third one? Okay, so what is that? V1 delta T, right? Plus 1/2 A delta T squared. Okay? V1 is 0. So I have half of 2, which is times 6 squared, which is, so how far did he go?
Excuse me for the interruption. Desiree Ellery to the art room, please. Desiree Ellery to art room.
All right. So I write change in velocity, but realistically there is no change in velocity, is there? He's going at a constant speed. How fast is he going in the second stage? 12 meters per second. Where did I get that 12 meters per second from? Stage 1. And what part of stage 1 did I get it from? V2. Okay. Time now. How long does he go for in that second stage?
30 seconds. 45 seconds.
What is it?
30 seconds.
30 seconds? Okay. How far does he go in stage 2?
360 meters.
Okay, I have a constant speed for 30 seconds. So I'm going at 12 meters per second for 30 seconds. So how do I find out what my displacement is? I just simply multiply them. So what do I get? 360 meters. All right. Now in that stage 2, I only have the 3 variables because it's a constant speed. But in stage 1 and stage 3, I have acceleration involved. So I have, let's see, Jeffrey. So I have to do all 5. Okay? So in stage 3, what is my V1? 12 meters per second. What's it give us as my acceleration? Doesn't give us an acceleration? Okay. We have to solve for it. What's my V2? Comes to a stop. And how long does he do it for?
5 seconds.
Takes him 5 seconds to stop? Is that right? Okay. Now in theory I don't need A. I don't need A here. I could find A, but I don't need it. Because what is it that I need from all 3 stages? I need my distance, and what else? Nope. My time. In every one of those 3 stages, I have to have the distance and the time because the average velocity for any question is your displacement over your time. So if that's the case, then I need my total displacement because he's moving away the entire time. He never changes direction. Just constantly moving away. So your final displacement is whatever the sum of all the distances are. Okay? And the time just keeps going. So I need my distance here. So how do I get my distance? What do I have? V1, V2, and time. Equation 2. V1 is 12, V2 is 0, 12 plus 0 is 12, 12 divided by 2 is 6, 6 times 5 seconds is 30 meters. Okay? Now to get my average velocity. Velocity average. My total displacement over my total time. What's my total displacement? 426 meters. What is my total time of this trip? 41 seconds. How do I get my average velocity? 426 divided by 41.
10.39.
In theory, I should have a direction, but it doesn't designate anything, so as long as it stays positive, it's fine.
Could you just put a velocity please? What's the maximum velocity?
No,
What's your average velocity?
that's my average velocity. What was the maximum velocity in the question?
12.
12 meters per second.
Mr. Newton, where do you get that 12 from?
Morgan, I start from rest.
Mm-hmm.
I'm accelerating at 2 meters per second squared
Mm-hmm.
for 6 seconds. Okay? What's the problem?
I should probably know this, and I don't know why I keep on forgetting this.
Well, to get your V2, Morgan, I can use that equation, but I asked the question logically without using the equation. so that you would understand it. If I'm starting at 0 and I'm accelerating at 2 meters per second every 1 second. So each second I'm going 2 meters per second faster for 6 seconds.
So 2 times 6.
That's how I get 12 meters per second.
Okay.
Okay? So the equation I use is to get my second velocity, v1 is 0. I take my a, which is 2, and I times it by 6, which is 12.
Okay.
You get that?
Yep.
Makes sense? You sure?
Yeah, it does.
Okay, good. All right? Okay, any other questions about this? There's at least 4 questions like this in that review. You are guaranteed to get one on your test, if not 2. All right? So you need to know that. The parachute question, you need to know that. I can guarantee you you're going to see that on your test.
What number is the person question? 46. I have it.
Okay, cool.
Pete, maybe, do you see that little graph on the side?
Yes.
Could you quickly help and tell me how I would get how the displacement for the first 5 seconds?
You have a triangle, oh no, displacement for the first 5 seconds? It's a distance time graph, right?
Right.
So
I'm saying if that's velocity, how would I?
if it was velocity,
Yeah.
then you find the area of the triangle. Okay, look at page 81, look at the graph at the top with A, B, C, D,
There's an E there too.
and an E, yeah. Okay, so if I was trying to find the displacement of that graph, I've got the first 5 seconds of it. It goes 30 meters per second. So I take 30 times 5 divided by 2. And that gives you the displacement. So that's how far it went in the first 5 seconds.
Oh, okay, so I just need to divide by 2.
Because it's a triangle.
Oh, okay.
Right.
Got it.
And then if you look at section B, for that 5 seconds, okay, in section B, I think it's 5 seconds, 10, 11, looks like 6 seconds, sorry. For that 6 seconds, you're going 30 meters per second. So you're going constant speed, so that's a rectangle. So you're just taking 30 times 6.
I just needed to know when it was just going up, how to get that.
Yes.
Easier than that.
Yes, or in the areas of the shapes. Okay?
Will the graphs from that assignment be on the test as well?
Yes? Let's see.
I have a question, number 36. 37. Page 85.
Okay.
Not sure if that's, it says nearby and right, but I'm not sure if that's one you're not supposed to do now.
Yep, you can. We've done it already. Turtle is moving at a constant acceleration along a straight ditch. He starts a stopwatch as he passes a fence post. Okay. This question. So, I've got my fence post right here. So that turtle starts right here. His V1 is 0. And he's moving at a constant acceleration. And when he hits the fence post, it takes 10 seconds to reach a pine tree 10 meters further. So you got your pine tree over here, right? Okay, so that's 10 meters. So my displacement in this case is 10 meters. And it takes 10 seconds to do that, so that's 10 seconds. Problem is, I'm going to start this, I'm going to do this in 2 stages. So stage 1 is before you get to the fence post. V1 is 0 meters per second. A I don't know. T I don't know. D I don't know. And V2 I don't know any of those. Okay? That's before the fence post. Once I hit the fence post, my V1 I don't know, my V2 I don't know, my A I don't know, my D I know is 10 meters, and my time is 10 seconds. Right? As he passes the pine tree, his speed is 1.2 meters per second. I lied, I do know this. That's 1.2 meters per second. Okay? How far from the fence post was when he started? So I'm looking for this right here. Okay, so this question is working slightly backwards from what you would think. When I did the first question, my board worked this way. I worked left to right. I started on stage 1, I went to stage 2, and I got to stage 3. And the information from stage 1 carried on to stage 2 and carried on to stage 3. In this question that we're doing right now, I actually have to work it backwards. Because I only know one piece of information on this part right here. That's all I know. So what is the information that I can get here from this board right here?
You would V1 on stage 2 and V2 on stage 1.
Exactly. If I get this, it's that.
Near acceleration is a constant acceleration.
My constant acceleration here is the same as it is here. So now, if I solve this question here, this part of it, uh-oh, I don't know what I did there. I don't want that. Good. If I solve this part of it here, I can get, I'll have V1, I'll have A, and I'll have V2. I can find out what D is. So you need to use this information right here to get V1, and you need to get A. You think you can finish it now? Okay? So you see how that works?
Yeah.
Alright, so I've got V2, T, D, and T. I need A, that's equation 4. And then I've got V1, I need to get V1 from V2, D, and T. That's equation 2. And then you use that information to get you into here. Okay? Other questions today? Sam?
12.
Yes?
Yeah, that's one of the videos, Matthew.
Okay. Oh. All right. Question 12 is a little sample size of the parachute question, but it's not the entire parachute question. All it does is it talks about the first part of this question. A balloonist jumped from a balloon at an altitude of 23,300. Now normally I would say, okay, well I've got a distance, 23,300 meters. But that's how far above the ground you are when he jumps. Now, the parachute is not going to open when he hits the ground. Might be a little too late. I don't know. Right? So, I don't have a distance of 23,300 meters. I don't use this distance in this question. Because, not at least at the start of it, because that's not how far he's going to fall in the first part of this. So he fell with an unopened parachute for 178 seconds. So what I do know though is this. My V1 is 0. You're jumping out of a plane, it's 0. My acceleration I know is 9.8 meters per second squared. I have 178 seconds of free fall. So what are the two pieces of information that I'm likely going to have to find? Without reading the question, what do you see missing right here? Pardon me?
V2.
Right.
But doesn't it kind of give you your V2?
V2 and D. Okay. So now I go back to the question. It says the balloonist was traveling at 62.6 meters per second when the parachute opened. Okay. So we've got to backtrack a little bit here. We assumed that our acceleration was 9.8 meters per second squared. All right, now anything that falls, if we neglect air resistance, which we normally do, with the exception of this one question. If we neglect air resistance, your acceleration of gravity, not your force, your acceleration of gravity is 9.8 meters per second squared. But it doesn't say that. It says in this question that I have now fallen for 178 seconds and I'm going at this speed when the parachute opens. What is the acceleration? So what do I have? V1, V2, and T. I need to find my acceleration. Well, the very first equation that we started with was change in velocity over change in time is equal to acceleration. So I have 62.6 minus 0 over 178.
0.352.
Meters per second squared. So what was the average acceleration? 0.352 meters per second squared. Why was the value of the average acceleration less than that for gravity? Air resistance. Okay? Which is what seems here to be quite significant, clearly. This should be closer than to 9.8 than it is. But that's exactly what it is. Okay? All right? Again, my suggestion to you, if you do not understand the question, if you're trying and you're having difficulties extrapolating the information from the question, then the very first thing you do is write out that right there. That's how you start every single question. Write out V1, A, T, V2, and D. And then say, okay, what part of this question is giving me those pieces of information? That's the very first thing that you do after you've read the question in its entirety the first time. So I read the question once. I get a basis. What are they asking? Is there stages? Then I write out the pertinent pieces of information first. And then from there I try and figure out, okay, if there was stages, how does this affect the next piece of the information that or the next stage of information that I need? Okay? Other questions today? Petra.
I like this question.
Okay. Go. 49, page 87. A convertible with its top down drove towards the entrance of an underground garage with a velocity of 24 kilometers per hour. A window cleaner on a scaffolding directly above the entrance accidentally kicked a bucket of water off a moving scaffold. The scaffolding at that moment was 9 meters vertically higher than the top of the car, and the car was 12 meters from the entrance. The scaffold was moving up at 1.5 meters per second. Did the driver get wet? This is a great question. So, how do I find out? Just think this through for a second. I've got a car driving towards the entrance. A bucket of water falls off. What is going to tell me? What is it that they can tell me? How do I determine whether or not the car gets wet? What?
Speed.
Speed? Well, it's going to be a factor. But what is going to actually tell me, did it get wet? What am I? The time. The time of what?
When the driver crossed the path of like the...
Of where the water comes down. Very good, Rory. That's exactly right. Okay? the time at which the car reaches the moment where the water hits the ground. You agree? So what am I looking for? I need to find the time it takes the car to get there using the velocity. Is that what Garrett said? And then I need to find the time it takes for that water to hit the ground. So let's start with the car. Constant speed, yes or no? Is there any acceleration involved?
No.
So then it's going at a constant speed. What's that constant speed? 24 kilometers an hour. So let's change that 24 kilometers an hour to meters per second. 6.667 meters per second. That's how fast that car is going. How far does he have to go before he hits the bottom of the scaffolding? A distance of 12 meters. So how do I figure out the time it's going to take for the car to get to the bottom of the scaffolding?
Divided by 6.
What is it?
Distance divided by velocity.
Distance divided by velocity. Distance of 12 meters divided by 6.66 repeating. 1.8 what? Okay, good enough. Thank you. So it's going to take 1.8 seconds for that car to hit the bottom of the scaffolding where the water is falling. So now what's the next thing that I have to figure out?
How long it took the water?
Okay, did you get that far? You got that far? So here's where we run into the problem. What do you think it is? Well, let's figure it out together. What is the issue that we're going to have? The issue we're going to have is right there. What is my initial velocity? 0.
It's moving up at 1.5 meters per second.
So what's my initial velocity then?
Negative 1.5.
Very good. Petra? There's the catch in the question. If I drop something normally, like this, if I drop this right now, my initial velocity is 0. However, if I'm moving up and I drop it, it has to start with the initial speed that I'm moving up at. Now, when I drop it, it's going to fall down. You agree? Okay? So it's working in the opposite direction. Now, if I was moving downwards and dropping it, it'd be a plus 1.5. But because I'm moving in the opposite direction, the actual water is going to fall. The initial speed is a negative number. It's a negative value. So I have a negative 1.5. What is the acceleration then? 9.8 meters per second squared. Does it say how high up it was?
9 meters.
9 meters. So what am I looking for? Time. Are you okay so far? Did you get that part of it? You got all the way there? Well done. So which did you use to set it up? That's right. Okay, so which one deals with V1, A, T, and D? Third one does. Agreed? So I got 9 meters. I'm not going to put the units in here. I got 9 meters equals V1 negative 1.5 T. Okay? Plus 1/2 9.8. 4.9 T squared. Okay, we've had this scenario before. What is it that I need to do? Okay, now, this scenario is different than any one we've had before. We've had one similar. So here's the issue. Okay? Go ahead.
Okay, never mind.
Oh, you have to keep it.
Factor.
Yeah, factor
Oh,
it out.
I'm gonna have to factor it, but before I factor it, what do I gotta do?
Greatest common factor.
Get rid of the negative. Or,
Make it a 0.
Make it equal to 0. So I've got 0 equals 4.9 t squared minus 1.5 t subtract 9. Okay? So now, the thing is with this, I won't give you one that isn't factorable. What's the first rule of thumb? What's the first rule we do when it comes to factoring? Greatest common factor. So I would actually divide everything by 4.9. That would be the first thing I do. Okay? But I'm still going to find out that the numbers don't jive. The numbers don't jive for this. Okay? I can't factor this nicely. So if it's not factorable, then I have two choices. What are the two choices?
Oh, you can use like the ax squared plus bx plus c and graph it
You could graph it, yes.
like that.
That would be number one. Okay? But we don't all have calculators here that can graph. So what's the second option to this question? Yes.
Couldn't you use number 5 to find V2 and then find time by V2 minus V1 by the acceleration? Then you'd find V2.
Okay, we'll come back to that and see if it works. Okay, let's do it this way first and then we'll come back. So what are the options here?
Can you just include the negative 9 and then put brackets around the 4.9 t squared minus 1.5 t and then take out the t?
Okay, you're ahead of the game here. I would have actually done that right here. I would have done that right here. Rory's right. And this is how do I say this? This is a method of factoring that we don't use very often, but that is probably the best method to use right here. Okay? So, for those of you that are in grade 11, we did this. We did it like that. Then you factor out a t. Okay? So, I'm going to do that first. This isn't the method I wanted to use, but I'm going to do it anyways. T. And then I'm left with 4.9t minus 1.5, and that has to equal, so now what I'm saying is, okay, well, what value? This goes back to the zeros. Okay, so what are the values that are going to give me, when I multiply this by this, the 0 is going to give me a 9. So the coordinate would become 0 and 9. So this is confusing. Okay, so what happens here is I'm going to end up with 0 and 9 as one of my coordinates. And then I'm going to end up with whatever 1.5 divided by 4.9 is. And 9 is my other coordinate. Okay? And so it doesn't really work all that well. So I'm not going to do this method. I want, personally, I want the second method. Now graphing works. And again, I said, I'm not going to give you a question in which you can't factor it. I want it factorable. But graphing works. What's the second alternative when you cannot graph?
Quadratic equation?
Quadratic equation. What's my A here?
4.9.
4.9. What's my B?
Negative 1.5.
And my C?
Negative 9.
Negative 9. So let's go to the other page here. And let's do that. X equals. Minus B, what was B? 1.5. Plus minus, square root. 1.5 squared minus 4 times, what was A?
4.9.
4.9. And C?
Negative 9.
Negative 9. And all of that is over 2 times 4.9. Equals. So let's finish this off. Okay. I want the square root of 1.5 squared minus 4 times 4.9 times negative 9. So give me the square root of that.
Negative 4 times.
We have 13.37.
What did you get, sorry?
13.37.
13.37 over 9.8. Okay, so now, if I use the subtract here, I'm going to end up with a negative number. Can I have a negative time?
No.
No. So then, I don't need the negative, I go plus. So what is 1.5 plus 13.37 divided by 9.8?
1.517.
1.517 seconds. Okay? Did you get that answer? You did? Okay, we're going to go back to that then.
Seems a little faster.
Okay? So I have 1.517 seconds. Did the car get wet?
No.
In mine, no, it didn't.
Hmm?
I don't think so.
No, because it hit the ground before.
How long did it take for the car to get there?
2 seconds. Oh, no.
1.8 seconds. How long did it take for the water to hit the ground? 1.5. Did it get wet?
So we just scratched
No.
the front bumper.
It splashed up on his bumper. Sure, we can go with that. In 0.3 seconds, it probably splashed it. Right? Okay, but he didn't get wet. Okay, so we're good so far? You okay? All right, let's go back to this. I'm going to erase this part of it, and we'll go through this using an alternative method. Now again, I don't like this method generally because I don't like using variables that I've solved for to get other answers. But in this case, the work might be a little bit easier if we do it this way. So the first thing we're going to do is let's find out what? No, we don't want it here. We want V2. We want to find out what the speed of the water is. Is that what you're saying? When it hits the ground?
Yeah.
So let's find out what the speed of the water is when it hits the ground. So I've got V2, I've got D, A, and V1. So I want to use V2 squared equals V1 squared plus 2AD. V2 equals. So I want the square root of negative 1.5 squared plus 2 times my A, which is 9.8, times my distance of 9 meters. Okay? So how fast is the water going when it hits the ground? That's what I want to find out. How fast is the water moving when I hit the ground? See it? What do you get? 13.37 meters per second. Now that has no use to us right now. It doesn't tell us whether or not the water's hitting the ground before the car gets there. That doesn't help us. But what it does do is it allows us then to use V1, A, and V2, so my average velocity, or my change in velocity and acceleration to get my time. So time is equal to, so VOT, so it's V over A, right? So I've got 13.37 minus negative 1.5 divided by 9.8. All right? We get 1.5, 1.517 seconds. That works for me. Much easier way to solve that question. Doing it this way. But what we've shown you in the past is to do it using that. You have the ability to do it using the factoring method. And like I said, if I give you this question, the factoring will be doable. But I'm also okay with you doing it this way. It's one of the few questions I want to see you use a variable that you solve for to solve the rest of the question. But it works. And again, why does it work? Because these 5 things are all related at all times. They're all related. So if you can list these out and find the missing pieces of information, so if you list all 5 variables out, every single question, and you found all 5 pieces of information, it would answer every question. Every single question would be answered if you did that. Okay? All right. Any other questions?
I just have a question, like, because do we get the formulas?
Yeah. Yes. Any other questions today?
There was one part about the beginning of that question that confused me, it's the velocity. And,
Of the car?
yeah, that, I don't know how you got that number.
I changed 24 kilometers an hour. I divide it by 3.6, and that changes it to meters per second.
Oh, so you converted it,
Yes.
okay.
Okay? Okay, you have till 20 after to continue to work on those questions.
So, for 15, when it says this is the acceleration, hours, kilometers per hour per second, can I leave it as that, or can I change it to meters?
If the rest of the question is in SI units, then you need to change it to SI units.
It's just all of it.
And you can leave it in kilometers if you like.